Elemental cost analysis (ECA) is a method used to break down the cost of a building into its main components or elements such as the structures, finishes, and services. This helps both the client and the project team understand how the total cost is distributed, allowing for better budgeting and planning. ECA is useful in the early stages of design as it provides a clear picture of where money is being spent. It also allows for cost comparison between similar projects, helping stakeholders make informed decisions. For this assignment, the chosen project is the proposed 68 units of three-story storage shop offices for phase 1. Is located in Samalaju Industrial Park, Bintulu, Sarawak. This commercial development includes mechanical and electrical services. Also is designed to support the industrial activities in the region. The report will analyze the cost of this development using ECA and provide insight into cost breakdown, benchmarking, and project specification. For project background, the project is called Proposed 68 units of three-story shop offices, Phase 1, and is located at Samalaju Industrial Park, Bintulu, Sarawak. The client of this project is Samalaju Properties Sendirian Berhad. They aim to provide commercial facilities to support the nearby industries and communities. These phases include 34 shop office units across several blocks. Moving on to the contract and tender, the project use fixed price of bill quantities contract and applies selective tendering. In this project, 17 contractors were invited, but only 10 submitted the bid. The awarded contract value was 50.6 million Malaysian ringgit. For the site condition, the site was undeveloped and required clearing, leveling, soil treatment, and utility connection. Um, Despite the flat terrain was generally flat, proper drainage and soil compaction were necessary. Next is the design complexity. Um, Even with modular design, the building included M&E system, fire safety measures, and flexible layout. The design met local codes and allowed for various purposes like offices and F&B. For the site for the market condition in 2015, the market was stable with moderate material price fluctuation and active contractor participation. The location under the score plan made the project attractive for competitive bidding. For Form 1, it mainly focused on project information. For the project details is proposed 68 units of three-story shop offices, phase 1, and is located at Samalaju Industrial Park, Bintulu, Sarawak. This development was commissioned by Samalaju Properties Sendirian Berhad with the objective of providing commercial spaces within a growing industrial zone. So the contract details is the contract type used for this project was fixed price with bill of quantities under the JKR Sarawak form of contract 2006. The tendering method was selective tendering where 17 contractors were invited and 10 submitted bids. The contract was awarded at a value of 6 15 million point six Malaysian ringgit, which matched the lowest tender received. This commercial development includes the construction of three-story shop office building with mechanical and electrical works. The total gross of the total gross floor area (GFA) is 4,140.01 meter square with 3,512 and 5.3 meter square um, of usable area, 257.74 meter square of ancillary space, and 3,094.72 meter square of non-enclosed space. The building consists of repetitive floor layouts designed for flexible commercial usage. The floor height the floor to floor height is 4,200 meter square at ground level and 6,300 meter square above ground floor. Provisional sum amount to 965,776.50, while preliminaries are stated at 982,890, which is 5% of the contract sum. Although the contingency are not listed, the form provide a detailed functional and spatial breakdown for accurate cost analysis. This information forms the foundation for the elemental cost breakdown and benchmarking used in subsequent section of the report.
So now we're moving on to the next section, which is Form 2, Summary of the Element Cost. So the project under review is a multi-story building with a GFA of 4,143.01 square meters. The total construction cost, excluding the contingencies, is approximately RM 5,997,158.40, so which gives an average cost per square meter of RM 1,447 ringgit and 54 cent. This cost is divided into six major components, which is substructure, superstructure, finishes, fittings and furnishing, services, and external works. So for the first element, which is substructure, includes works such as piling and construction below the lowest floor finish. So the total cost for this component is RM 1,440,156 and 70 cents, representing 24.01% of the total building cost. So for the second element, superstructure contributes the largest portion of the total cost with a value of RM 2,358,574 or 39.32%. This category includes the main structural components such as the building frame, upper floors, roof, staircases, and both internal and external walls. So for the costs associated with internal partitions, staircases, doors, and windows are also included under this element. The distribution of costs in this element reflects the major materials and structural labor required to erect the building. So the third element, finishes, has a total cost of RM 828,000.0, which is 13.81% of the total cost. So this includes wall finishes, floor finishes, and ceiling finishes. So this indicates a strong focus on internal comfort and aesthetic, which is ensuring that the interiors are functional, clean, and pleasant for the occupants. Moving on to the fifth element, which is services. The total cost allocated is RM 1067 ringgit 450 cent and 50 ringgit and 90 cent, making up 2.79% of the total cost. This element includes essential building services such as sanitary appliances, external installation, protection, and minor provisions for refuse disposal. But however, No cost was recorded for major mechanical systems such as lift, air conditioning, and communication installation. So this could mean that those systems are not required for this building type or had not yet been specified at the time of the analysis. The sixth and final element, external works, accounts for RM 2,200, 121, 21 ringgit and 80 cent or 3.67% of the total cost. External works include site preparation and development, drainage system, and miscellaneous items or sundries. Although this is the smallest element in the terms of cost, it plays a crucial role in ensuring that the building's functionality and integration with the surrounding environment. In summary, the three largest components of these buildings costs are first superstructure, second substructure, and the third one is finishes. So, in conclusion, ECA is a vital method for QS to understand how the total cost of the building is distributed. It assists in cost planning, tendering, and value engineering. By breaking down the cost into elements, stakeholders can identify areas for cost control and decision making. This ECA Form 2 presentation has provided a structured and detailed overview of the cost distribution in a typical building project.
Hello and Assalamualaikum. My name is Wardina Wardah binti Jodni. So I will be presenting Form 3. Now let's look at Form 3, which is brief specifications. So Form 3 provides a concise but essential information about the specification of each element in the project. So it outlines the materials, components, and construction quality used in each element, such as substructure, superstructure, finishes, fittings, and so on. So, this section helps us to understand the level of the quality, whether it's basic, standard, or high end, so that we can just justify the cost that's shown in Form 2. For example, if the finishes cost is lower than average, Form 3 might reveal that economical materials like ceramic tiles or emulsion paint were used, which explains the savings for the cost. It also helps stakeholders to compare costs more accurately by understanding what's actually included in each element. Without Form 3, the numbers in Form 2 would lack context. So this form plays a supporting role in validating the cost structure and adding in future cost planning or project benchmarking. Next, we're moving on to cost benchmarking. So, cost benchmarking is a method used to compare the cost performance of our project against industry standards or similar developments, and it's usually measured in cost per square meter. So, for this project, we use updated 2025 benchmark data from reliable sources such as PWCIC and CIDB Malaysia. So we look at the key elements like substructure, superstructure, finishes, external works, and preliminaries. So what's important is that all our project elements were below the market average, which shows that the project was cost efficient without sacrificing functionality. For example, the substructure cost was 4.76% lower than the benchmark. This is impressive, especially if piling was involved due to soft ground. Next is the superstructure, which is 22.01% below the benchmark. So this suggests that the use of a simple, repetitive reinforced concrete frame helped to control structural costs. So for the finishes it was 26.65% lower the benchmark, likely due to practical materials like ceramic tiles and emulsion paint. So next is for the external works cost was the most efficient at 30.53% below the benchmark. This makes sense as the project is in an industrial park, so there was minimal landscaping or decorative features. Lastly, for preliminaries, which is 12.14% below average, so this shows good site management, efficient scheduling, and resource control. So for conclusion, this benchmarking shows that the project was very cost effective, making smart choices in design, materials, and planning, all while maintaining functional performance for commercial use.
In this part, I will be presenting cost benchmarking for services. So, building services for this project only account for 5.88% of the project's overall construction costs, which is substantially less than the industry average of 10% to 15% for comparable buildings. There could be multiple reasons for this deviation. Firstly, comprehensive M&E systems like lifts, HVAC chillers, and smart building controls are not necessary for the shop of this typology. The services offered are probably minimal and ordinary, appropriate for simple commercial use. Additionally, costs associated with services might have been decreased by efficient design or competitive tendering. The elemental breakdown may not have fully incorporated certain service-related components, such as external works or tentative sums, which could have been included under other elements. Even though the price is lower than usual, it might nevertheless represent effective and suitable service design for the building's type and purpose. To ensure that crucial M&E requirements are not under-specified, especially with regard to long-term maintenance, compliance and performance, care should be taken.